Hello and welcome to a little bit of an interesting video where I want to explore the world generation of Hytale. Now, if you don't know what Hytale is, it's this game that just released out in early access that is pretty much very similar to Minecraft, except one of the things that they very much touch on that is better than Minecraft is its modding capabilities, which I think in a way is kind of coming up to be true, because I want to show you kind of how easy it is and the setup to making your own worlds in Hytale. Now, to start off with, I actually kind of want to direct you to a Minecraft video, which I know is a little bit weird, but this is a video about the world generation that currently works for the Caves and Cliffs part of Minecraft, made by Henrik, original developer for Mojang. And I think this is just a really good video. I'm going to include it in the description. That kind of goes over just in general how world generation works. You can see he's just taken a chunk of the world and is explaining it step by step, and I think it's just very useful to know. Now, the second thing I do want to mention is that I didn't learn this completely by myself. There is some guides out there, including this one, as well as this one here, which I'll also include in the description. Very, very good written documentation, which I know that written documentation at least helps me a lot learn things. And I've also been working on my own kind of Excel sheet document here, which goes over as much as I can about what the nodes do from my little bit of testing, as well as kind of the file structure of how Hytale works in terms of its world generation. Alright, to start us off here, I want to set up a new world for terrain generation. So I'm going to call it just World Gen. I'm going to create the world. Doesn't matter what you do in the beginning setup. I think this will just boot us into the Creative Hub, I believe. Alright, so the world has loaded, but the first thing that you want to do is actually go into your file structure. Now, this is very important in order to use the asset node editor, which is an extremely useful tool for creating worlds. And you'll find this in the Hytale folder, which is in the app data, and then you go into install, release, package, game, latest, and then in your assets.zip, you want to go to server, and then you want to copy over the Hytale generator folder. I've copied this over into my own personal folder here. And you'll see this is important because if you go into, well, the first thing you need to do is op yourself. And then if you hit B and go into Creative Tools, Asset Node Editor, you'll be able to open up the existing nodes that Hytale uses in order to generate its biomes. So in here you can see this is the same folder, the Hytale generator folder, and then I can go into Biomes, and let's just open up a random taiga one. And this is where you'll essentially be learning a lot of what the nodes do and how the nodes operate in the current existing version of a lot of these things. So that was the Taiga 1 river, and if you want to go to there, you can type in instance, and then you can go to zone 3 Taiga, spawn in, and here we are. And you can see that the river biome that was referencing is this one right here. So now, for example, if you want to change this generation or use some of its generation in your own worlds, now you can simply open up this node editor and copy over some of its values. Or if you go and open up another building tool, the asset editor, which you'll be able to do most of your stuff in, you'll want to first add a pack, just call it New World Gen by me. Alright, save that. Create a new asset here. It's going to be a biome asset to replace that Hytale taiga. Oh, let me type that in correctly. I always get the A and I mixed up in taiga. But the Taiga 1 river, and if you name it the exact same thing, you will be able to override it in your own pack here. So you can see that you can also modify it in here, but if you want to actually modify it in the asset node editor, you'll want to actually open it up in your saves folder. So for the world gen, for the mods, and then this is the mod that we've just created, and if you go into server, Hytale Biomes, this is the one that you just created. And you'll want to essentially just copy this, go over to here, open, and then go over to that file structure, open up here, and it should look the exact same. It works the exact same, and now you can modify it. So if I want to create a flat terrain, I'm going to explain this a lot more in depth later, but I just want to create a base height map with a curve mapper. Whoa, that's Interesting. Okay, I for some reason found a weird bug where it thinks I'm just holding down the control button. Okay, there we go. I fixed it. I just hit control again. Yes, so I'm just going to do a very quick just setup here. I need to actually delete this connection just to make the river be flat. And so then I just quickly set this up here. I'm going to hit save. I'm going to join back into the world. And you're not going to see anything yet. That's just because you need to reload it using /World Gen reload clear. And this will actually just delete and reload all your chunks. And in theory, this river should be pretty much the same height as the rest of the base height map. Which, if you're not seeing anything happen immediately and you didn't see like a node save in the bottom right corner, you may want to quit and then rejoin the world. I found that sometimes just happens. Or it could just happen over time if you keep on reloading your chunks a lot. I think it's just kind of like a memory buildup, and you just need to kind of clear the cache and then rejoin back in. So now you can see everything that is river looks like this. Let me just reload the chunks again, just to make sure that they all kind of load in properly. Yeah, so now all of the river chunks is just going to be this base flat height map here, which is very useful to override some of the biomes. But of course, what if you don't want to just override an existing instance? You want to create your own instance, you want to create your own dimension. Well, I have figured out how to do it. It is a little bit of a workaround because it actually isn't in this asset node editor here, which I need to reopen since I've closed and reopened the world. But yeah, as you can see, there is no instance folder in here. However, if I go into the assets here in the server, I can see that there is an instance, and what you can theoretically do is you can take like zone 3 tag 1, go over, copy this, and put it into your mod folder into the same folder structure, instances, put it in here, put this in here, rename it to custom, or I'll just name it my terrain right here, name it my terrain, and then in the instance .bson, I'm just going to open it up into a random text editor, which is this case going to be this one. And so the world structure right here is the main thing that you'll be focusing on in this instance. You can change a lot of other things, like for example the game mode and all that, but the main one we'll be focusing on is here. So I'll also name this my terrain, save this, and then go up back into the asset node editor. And then what I want to do is create my own world structure asset called, again, the same exact thing, my world, right? That's what I called it, my terrain. Yeah, so I'll copy over the Taiga one because I think it's a very useful beginning platform in order to learn a lot of this stuff. But if I create this, my terrain, then theoretically, if we go back into Hytale, we'll have created our own dimension. Yes, my terrain right here. Cool. I wasn't sure if I had to reload, but it looks like it's all loaded up. And theoretically, it should look exactly like the tag that we saw before. And falling into here, yep, it is the exact same. So now through this, you can see our rivers are still flatlands. But through this, we won't have to overwrite, for example, the V1 terrain or the taiga terrain or any other terrain. Because, for example, if I only want this river tile to be spawning in this instance and not overwriting the other one, I can go into the asset node editor and then should theoretically be able to rename it to my taiga 1 river. Rename it here, and then in here I want to rename the biome that is referenced, which I believe is this one. Yes, I'll go into my taiga 1 river. If I save this and then go back into Hytale, if I go back to the other instance of the original taiga, spawn back in here. Alright, here we are, and then let me go and look at a river real quick, see where it is. By the way, some useful tools: F1 will slow you down, F2 will speed you up, and then F3 will disable collision so you can float through and check to see if like cave generation is working, for example. And as you can see, floating around, the rivers have kind of gone back to how they are and how they should be generating for this world, which is great. And I didn't have to override this this biome. And so then we'll go ahead and hop back over to our custom terrain that we have over here. Alright, here we are. And then begin experimenting more with the world generation, which the first step is actually the noise, the density. Because as you can see, our world is very flat right now. You know, this is very boring terrain to go over, and so that's why we go into our most important step, as I was talking about before, these noise patterns. Now, this article is actually pretty good to explain some of the example biomes that Hytale comes with, because if you open up Hytale, you'll actually come with a lot of example biomes that you can try out in terms of the densities. So you can see examples here. You have example twist craters, you have fake 3D noise, you also have experimental where you have arches, a basic forest, a curse breaker key art biome, which sounds pretty exciting. You also have something, which also sounds exciting. But if you want to take a quick look at what these look like, again, I would encourage this article right here. For example, cell noise 2D. This is a very good noise that I like using a lot, and whenever you generate the world, it'll look like this. Another one, another very useful thing that Minecraft does actually, which let's see if I can pull it up here, is splines. So as you can see in here, in this example, this is an example of splines. So in terms of continentalness, whether it's ocean or land here, he's essentially mapping that if you get to a -1 in terms of the noise pattern, it'll be in the deepest part of the oceans. But as the noise pattern reaches 1, it'll enter more and more land territory and create this very specific plateau where the land begins. And you can see that in effect over in here. You can see that as it reaches the land, it'll go up. And if you get to a certain continentalness in the noise pattern, then it'll create a very steep mountain. And it's something that very cool that you can do in Hytale. And then just going through this, you can see lots of other examples that I very much encourage you opening into this asset node editor here to really kind of see how a lot of these things work. Like these twist craters look very interesting in terms of how they generate. It's really cool. Interpolation A, interpolation B, runtime defect. I think this is just kind of spawning in structures or features into the land, like for example trees. Vector provider, they said this one's really complex. I haven't looked at it yet, but this is also some crazy looking world generation that I very much encourage you also opening up in the asset node editor. But to start off with, I want to actually open up just a very simple terrain. Let's go with, for example, the redwoods. So I'm going to open up the default Hytale generator, and then I'm going to go into biomes, and let's try out the Taiga one redwood, which is the forest that they have. So going into here. Up here, the terrain, which is again the shape, is the density, is the noise map. So right here you can see it has a lot of very specific noise patterns that all kind of culminate into the same thing, but the best way to do it is to just break it down. And also a very important note is that if you've ever used Unity's node system for like shader graphs or things like that, a lot of the calculations go from left to right. This one goes from right to left, so it is a little bit confusing. You can mirror the node positions like this, but as you can see, the connection points are still on the other side, so it doesn't actually help much, and it's just better to read it like this. But let's start right with the very beginning here, the base. So right here, it's using, again, the simplex noise 2D, which again generates a simple noise pattern going from -1 to 1. In this case, they are mapping that -1 to 1 to a 0 to 1, and then getting the max density, so whichever one has its maximum will be used. And then going along here, it is then setting it all to a power of 3, which just makes it a lot more sharper whenever it comes to certain points, which will get you some cool looking mountains. And then this is then mapped from the 0 to 1 to -0.8 to 0.8. Again, if it's greater than 0, this will be land. If it's less than 0, it'll be air. And this is used as a sum density, so it adds on whatever this is to another simplex noise map. And this one also has octave 2, so again, going off of Henrik's video, this just adds more, I guess, kind of details into the noise map, which makes it a little bit more rougher and a little bit more kind of natural terrain. And this one isn't adding too much to it. The main density would be this bottom one. This is just a -0.2 to 0.2. Down here, this one is very important here, is to make sure that the height of the terrain, the base height of the terrain, remains this kind of very constant value. Essentially what this means is that this is a global variable, which is defined in the world structures. So world structure assets, if I go to Zone 3 Taiga 1, the content fields here, these are essentially just global variables. So you could theoretically actually go in here and increase this base, and then what that would do is it would just increase the height of all of this terrain, which is what I was doing to begin with here, testing out the river noise here. I essentially just put it all to this base value, using again this curve mapper. If you want any more like extra details on how any of these nodes work, again, encourage you to check out the Excel document I've made here, which goes into a little bit more density, like for example the curve mapper as well as the base height noise. But this will essentially just allow all of the biomes to remain around the same height of the base height here. And this is then again added onto these other noises, just to add a little bit more variety onto the biome height map. And then now this one is very important, and we'll get to it in just a second, but to begin with I want to go to this exported density here. This exported density is very useful in case you don't want to just copy and paste this whole noise map again, in case you want to use it again, because there's also another density node called imported density, and so if I name it the same thing of Taiga 1 rewood rewood underscore base, then this will essentially just export or output the same density as this initial one here. And again, it doesn't require just copying and pasting the same density again. However, there is one very important thing, is that if you keep on exporting and importing the same exact density, then it can get very cost heavy if you're having to do the same calculation over and over to get to the same density. And that's why, again, this cache density is very, very useful. It'll essentially just keep the results, and then anytime this is called and it's querying the same exact position in the world, it'll know already what this will calculate, so it doesn't have to recalculate it every single time, which again makes this exported and imported very useful. So I recommend, if you ever do export density, right before you cache it, just to make sure you're not doing multiple calculations that aren't necessarily worth it, because sometimes World Gen can be a little bit resource intensive. So this is all added into this mixed density node here. I'm not going to go into this cliff texture, it's just kind of going over a lot of the same stuff that I was talking about before. And if there's any new nodes, like for example this biome border node, right here, distance to biome edge, again, I have this Excel document for a reason, so I don't take hours explaining it in one video. But this mixed density I think is a very worthy node to go over, because as you can see right down here, you actually are using the imported density of the Taiga 1 redwood base, so it's using the same exact mapping here. It is specifically mapping it using, again, this spline, which you can see over here, to map it to specific values between 0 and 1. Now if it hits 0, it's going to use specifically the base texture. If it's in between, it's going to have a mix of both of these. And if it's just 1, it'll just use the cliff texture. Now this is actually a little bit more useful than just kind of mapping in between these two densities, because it can have some height optimizations. As you can see here, this is another mixed density. Again, mapping it between 1 and 0 to go in between mixing this specific density and just doing a constant density of 1. So this is specifically useful for performance, because whatever calculation this is doing may not all the time be needed. Like for example, I know that I was looking a little bit at this twist crater noise here pattern, and this is a little bit complex to actually generate these, but what it does to increase on performance is it actually only calculates it within this range. Everything else uses very simple base height map, which we've looked at before, and it never actually touches any of the complex math that would generate this. And how it does this is again using a mixed density, which is again very, very useful. So then jumping ahead, we're almost to the final density here. It is just adding a little bit of caves terrain, which is imported from the plains, which is actually kind of interesting that you can import and export densities from essentially different files, which is really cool to make the caves kind of flow the same between every single biome and not have a hard cutoff whenever the biome cuts off. And it looks like it is also just multiplying it by 4 to make probably bigger caves compared to the plains, because The taiga is a little bit bigger and massive in terms of its world generation, and it looks like it is also just multiplying that original density that we saw up there by 0.5 and then doing the minimum density between the two. And so the minimum density is essentially just saying take the air from both. And then that will go into this biome node. But again, it is a little bit complex, especially if you don't know a lot about terrain generation, which again, I recommend watching this video here and also looking through here. You can see a little bit about how the simplex noise works, a little bit of the cell noise in terms of what you can return in terms of the cell noise. But overall, I hope like what I explained is helpful enough to be able to start you on your journey of creating your own terrain generation and possibly being able to make those again like cliffs and stuff that you see in the game, like over here. This is using some complex like 3D noise to kind of carve out, to really define this this cool cliff here. So hopefully that was all a good little guide to explain how you can go from just those random noise patterns to something that looks like this, with these caves and this wild cliff generation here. But I should actually show a little bit of it in progress for this custom river biome that we have here. So let me go over to the asset node editor and then open that specific biome that we copied over, which would be over here. Hytale generator, biomes, my taiga 1 river. And then using a little bit of what we learned, I want to make it to where there are hills that are optimized and that pop through this base height here. So let's start off with, let's create the hills, which would be simplex noise. Let's do 2D as we're not creating caves here. The seed I'm going to name hills, just to make sure that it doesn't conflict with any other simplex noise that we may have. Alright, so now let's add this to the base height over here, see what initially this does. And a useful tool that I hadn't actually gotten to yet is that you can actually, in real time, load just a few chunks around you. So this will be a radius of 2, specifically just around this area. I don't think I hit save, so it won't actually work. But if I go in here, I'll put this to the side, I'll lower it a little bit, hit Control S. And then you should see that reloading assets for biome 1 is right there, and you should see something happening. And the fact that we're not just means that I should probably actually multiply what this noise is by to make it a little bit more pronounced. And we should see it reload. Yes, perfect. It is doing this, which is not exactly what I wanted. So let me do another useful thing, which is not /B, but pressing B, and then opening up another asset node editor, which is very useful so then you can compare between two different biome maps. So if I go back into here, I can then compare it based off of basic.json, which I think is a very simple biome map, which is essentially what I'm trying to do. And this is actually kind of what I had before, I guess. Oh, okay. I think I get it. Instead of multiplying this simplex noise, I should have been opening up the curve to have more values between 1 and -1, so that it's not just as drastic as a change as it was. So let me go over to my other one over here and make those changes back to essentially what it was before. But yeah, so now from the base height going from 0 to 50, you can see that I have some hills, but this is a little bit too much in my personal preference, so I'm going to change that back down to go from 0 to 20, go here, and then it should map back down to be a little bit smaller of hills that I wanted. Nice, nice. And so now I want to work on making these hills only pop out for certain sections, so that will require moving this, applying a mixed density, and then only calling the hills whenever I need the hills. Alright, so I've done something here. I haven't tested it yet, but I wanted to mix it to be based off of if there is a positive value in terms of there will be a hill, then I will be calling to this function up here to add the hills, and then if there are no hills, then I call back to the base height map, which I've exported here so I don't have to copy and paste and do the same possibly complex calculation over and over again. And I can already tell that there are a few things that I want to change with how this is working. In the terms of I'm actually doing the opposite and I'm only showing the craters and not the hills, because I have flipped the 0 and the 1. So let me go in here and invert the density. So if I go back into here, I should see the opposite to where the hills are now showing. And everything else is using the base height map, which is good, but most of the time this is still going between 0 and 1, so it is still calling both of these functions. So then what I want to do is then call the normalizer function, which will just essentially just remap the values. So if I detach this and put this in here, and then at specifically 0, if it's less than 0, then it'll just say it's -1. And then if it's greater than 0, I'll map it to 1, which actually I want to change this to 0 because I don't think the mixed density works with that. So let me save this, and then we should see more of a distinct feature between, a more distinct feature between hills and no hills, which is perfect. And so now if I wanted to do a complex calculation specifically for these hills, like let me go in and say that they have a lot of details on them and put them up to like 6 octaves here, and then I hit save. You can see it has a lot more detail to these hills. However, it's not being calculated everywhere like here, which is very important, just kind of little performance thing that I thought I'd share in this video. So now that I've kind of showed you an example of how noise works and also how to show a section that you can generate, if I want to again show this everywhere, I can do reload clear, but again this is kind of a cost, but this is kind of like a performance heavy calculation to redo it all, and this is very quick. You don't even have to hit anything. You just hit save in the node editor and then it pops up here. But if you are done with your noise, you can go ahead and go in and then just hit save and it'll apply everywhere. So very, very cool. And we will actually be coming back to the noise because we're moving on to the biomapping, which still actually uses noise. If you can believe it or not, all that World Gen is just a whole bunch of noise. So let me go back into my specific terrain here, my world structures, which is where, again, all the biomes are declared. So the main thing that we'll be looking at now is how biomapping works. Now, a very useful kind of explanation, or I guess visual, to show how this works. I do actually have a whole list of instructions of sort of how it works here as well if you want to read through it. But here's a little bit of a visual. You will have your noise values probably mapped between -1 and 1, and it will go through, and then you can set this range of different biomes to be matched to different ranges of values. And now this is right here, again, just using raw noise values, so it's not going to look too interesting here. But you can see, for example, if you call this part ocean, this one shore, this one like plains, and then this one mountains, you can see sort of how it could start shaping up. But if you want to get a little bit more specific of like specific biomes inside here, you'll need a little bit more of complex noise, which I'm going to open up here, and I'm actually going to do this by actually just copying over and then changing the density asset. So let me go here. The default one that a lot of them use is this map default, which I think is a very good one. Whoops, I need to call it something. I'm going to call it my map default, so I'm not modifying values of existing instances. So if I do this, hit create, and then go into here and then make sure that I'm now calling this new one, which this name is different, and the reason why that is, and I'll show you in a second. If I hit open, this is the wrong location. Let me go back into here. It would be very useful if you could just open it up through here. You can right click and then open up the node editor, but that is not currently how it works. So it is a little bit cumbersome to move through here. I need to go into here. Server, Hytale, generator. Let me go into the density and then my map default. This is the new one right here, and this is the specific name that is being used for here. So I'm going to rename it again to my biomap, just to make sure everything will link correctly. And the best way to tell is to change something. So a very useful tool right here is a debug scaler, and I recommend you always including a scale density in your projects here, to where you can actually scale everything to be much smaller, to where you can see if your biomapping is working, to where you can see essentially a miniature version of oceans, of shores, of inland, and of mountains. So yeah, let me save this, it should all save correctly. Alright, so I got a little bit of it loaded. It is just taking a while, I think because it's just doing a lot of calculations in a very small area. But yeah, as you can see, the oceans are now very small, the shores are very tiny, and then you have immediately mountains. Alright, so while we're waiting for this to load, I want to go back into here and go through a lot of how this stuff works. Alright, so to begin with, you can see that there are multiple steps that are used here. And let's start at the biome tiles, because, you know, I guess it's the top thing here. And this will be controlling the land tiles. So this is transitioning between the redwood forest and the mountains that you can see. So how this is working is using Veroni or cell noise, which you can see here. But essentially how it works is it creates a whole bunch of cells and then defines a biome to each cell. And a lot of times that neighboring cells will have the same value, which will be the same biome. I think this technique is actually really cool. It was a technique that I was doing in the first world generation, little dip into world generation that I was doing. And the reason why I was doing it, and I think why they're doing it, is because this doesn't create like small little biomes, because a biome has to take up at least one whole cell, which is very useful for actually being able to have big biomes and not have just small little things that could spawn here and there. Again, caching it is very useful. Why override density? This is just all clamping it to the XZ coordinates and just making it a 2D, because a lot of times that is just kind of what you want for a biomap. If you want to get into like cave biomes, I imagine you would be able to change this to work with biomes as well, just adding like another, like from -1 to -2, mapping it to specific cave biomes and using a combination of mixed densities and things like that to make it work. But yeah, so why override? You normalize it, so from -1 to 1, it maps it to -1 to -0.5. So specifically between these values will be land, is essentially what this is saying. And then the last thing that it does is it just does some gradient warp, which I believe I have a little example of what that does here. It essentially just takes your initial noise that you have here and warps it based off of another noise, which doesn't look like you can change what the noise is, but I don't think it really matters. It just, again, takes another simplex noise and warps it like this. Alright, so moving on, you can see you have a mixed density here, which goes in between, again, the land tiles and river. River will specifically be assigned to -0.3. So again, going here, -0.3 will be for river biomes. So going here, this is what determines river biomes, and this, I'm just going to pretty much simplify it. It uses a lot of noise patterns grouped together to make it work. But the most important part here is the absolute density, and it's something that Minecraft World Generation does as well to create its rivers. This is specifically for their caves in terms of how it generates, but the black will be stone and the white will be stone, but the border between black and white, which is this gray here, will be all the caves. So you can see based off of that, you can already get like a pretty good like noodle generation here, which I think is very useful. And again, they don't just do it for their caves, they also do it for their rivers, which creates a noise map which looks like this. This is their peaks and valleys map, and they use 2 absolute values, which one you can use for the rivers here, which again, the absolute value, actually I have it mapped here. The absolute value works pretty well to specifically have this middle gray noise be prominent noise where stuff will spawn. And then just kind of again, Minecraft also does this for their mountains to make it also kind of noodle shaped, which also allows little like groves to spawn in the middle of mountains. So if you've ever seen like a mountain range and then in the middle of it there's like a little peaceful area, that is on purpose using another absolute value to make that. But that is what Hytale does as well for their rivers. They take the absolute density, they go through, and then whenever they hit the normalizer here. Specifically 0.62 is where they interpolate between being river and not river, which as you can see here, this is 0.62. So everything within here would be river, everything not is using the other noise value. So again, the -0.3 and then all the land biomes. But this, you know, can't be done without also having oceans. So right in here, this is the main noise function here, which is the world continents map. It's a very simple one, which again, looking here, you can tell that you don't need much to determine if it's ocean or land. Even like comparing this looks like a good ocean to land ratio. They do have a couple other densities added onto here, which one is a land guarantee using a distance function. So the point at which you spawn 0, 0 will always guarantee land, and then outside of that, it then will use whatever generation here. Because you can see right here, if you spawn 0, 0, you'd spawn an ocean, and so then it'll just add like a little noise spot right here just to make sure that this will always generate inland and you won't spawn an ocean. And they also want to add in little islands and peninsulas, because as you can see here, if you just have the one noise pattern, you don't really get many islands and peninsulas. Taking the minimum density there, caching it, and then being able to export it, and then going here to probably make it a mixed density between, again, the land and the rivers versus the oceans. This is just taking the ocean value and putting it over here and then normalizing it. So if it's below 0, it'll be ocean. If it's above 0, then it will be land. And then they always put a clamp density after this whenever they go into a mix node. I don't necessarily know why, because I imagine it would already be clamped to -1 and 1. But anyways, to see this in actual action, you'll go back to the asset editor here, and then the density again is in here. And so from -1 to -0.5, you can see it's a mix between these two biomes here, Taiga 1 Mountains and Taiga 1 Redwood. And then what this actually allows us to do is be able to add in another biome in between that will spawn amongst these other biomes. So I'm gonna actually reference an existing biome again in Hytale. I'm actually just gonna include a volcano in there. I'll do a volcanic 1 caldera, and I'll want to change this. I don't know why it says -2. It is mapped from -1 to -0.5 based off of what we've seen there. And in fact, if you are doing this as well, it is useful going in between these to name these. So, for example, the Biome 1 tiles here, I would probably be naming this to just be easier to look up next time, to be like, okay, so from -1 to -0.5, I need to be mapping all my land tiles. So I am going to increase this, so from -1 to -0.8, it'll be this biome. From -0.8 to -0.6, it'll be the volcano biome, and then from -6 to -0.5, it'll be the redwood. So this is like a little example of how you can add in biomes into existing worlds. So for example, I could have copied over the taiga and replaced it, overrode it, and then added my own taiga biome onto that using being specifically within this -1 to -0.5 range. If I save this and then go back in, hopefully everything is loaded. Everything is very small, as you can see here. This is what I was wanting to show earlier. All the biomes are very small, but you can see how everything will work together. You actually can't see the rivers just because, you know, they're probably just too small to generate everything. So let me actually change that in the asset node editor to go back to the 1, 1, and 1. But that just shows you a little bit of an example of how you could check out that your biome map is working. I do recommend, I guess, if you are scaling it to 0.1, to using much simpler biomes and just coloring it, similar to how this is done. I do wish they had a feature in the asset node editor, like the shader graph in Unity, where you had like an example output of what it would look like underneath each of these, to where you can kind of better see it instead of always having to rely off of Hytale loading it. But oh yes, perfect. This is exactly what I want to see. It looks like we have volcanoes actually just spawning in the world now, because this is probably using the biome edge density, which allows this to happen, which is a very cool example of it actually. And I was hoping that it would actually be a volcano, which is really cool to see. But yeah, you can see the biome edge density, it's just going up, and then once it reaches a certain point, it goes into this density map instead, which is really cool to see. But anyways, so yeah, that's technically how you add in your own biomes into a previously existing world. Oh, and there's the dragon slumbering there. But yeah, and again, I didn't go into it, but I believe that if it's probably just like -1 or something like that, it is going to map to the ocean, which I can then, again, double check here. This will be the 3 land tiles. This will be the river, which is my Taiga River. from negative 0.5 to 0, which again the value was setting was negative 0.3, and then I believe from 0 to 1 then it would be ocean. So if we go here, this is the shore. Oh, from 0 to 0.15, this is also very useful to just this section right here before it really gets into the ocean. It'll have a shore, and then after that it will actually be ocean. And then if you forget to map anything on here, like you accidentally forget the range, like negative 0.3 to 0, again, that's what this default biome is for, is to just replace anything that's not referenced to oceans. It's just a little check for that. Another very interesting thing that it includes here is this default transition distance and max biome edge distance. I assume that the default transition distance is for whenever two biomes are next to each other, since they both use a different height map. There is kind of a little bit of blending, as you can see, as it reaches the new biome, based off of both of their height maps and just kind of blending them together. And then I assume then that the other one here, the max biome edge distance, this is just probably the larger value this is, the more computing power it would be. But for 48, it only checks 48 blocks in to the biome edge, which again is very useful for things like volcanoes, or if you have like a structure that is specifically supposed to spawn in this biome, but it is like a large structure and you don't want it like leaking out into another biome. Like for example, you need the structure, like a very good example is you need the structure to be on flat land and you don't want it to like be intersecting into a huge mountain. You can make sure with that biome density with that biome edge density that it is spawning within that specific zone, which I believe the max value would be 48 based off of that. And that is, again, sort of a brief preview of the biomapping, and as I did before, I will show that I know what I'm talking about in terms of adding some values and changing up what it does. Now, it didn't go great last time. It required a lot of debugging, but isn't that most decoding? Debugging, so let's do this. So what I want to do for this example, I want to not only change what biomes can spawn here, for example this volcano, I also want to change the size of the ocean. So theoretically, since there is no other normalizer, I believe it is just pretty much half and half oceans and half land. So I'm actually going to map it to where instead of going from -1 to 1, I want to decrease that value to probably -1 to 0.5 to just make smaller oceans. And before we do this, I actually want to go to an ocean to really compare to see that this is working properly. Another really cool thing that I really like about this world generation is that it the fog is based upon not only the environment but also how many chunks are loading. So you can see as the chunks are loading that the fog is just interpolating between how many chunks are loaded. So as you can see, this is a lot of ocean. Let me just check that it's ocean by going down here. You can see the very distinct ocean boundary here, and also again going into F7 twice. Environment zone 0 is tied to the ocean. Environment zone 3 is shores, which I'll also go into explaining a little bit of the environments at some point. So what I want to do is, you can see that while there is a lot of land, there's also a lot of ocean. So I want to remap it to have less ocean. So if I go to -1 to 0.5 instead, and I hit save, but theoretically you should see that the land will remain the same, which now you can't actually see the land at all. I was too far away over here. Yes, so you can see the land over here. It's mostly remaining the same. Yes, perfect. I'll be over here. Yeah. And instead, it is just adding on to that land all the way until it hits the ocean. But yeah, you can see that this is sort of ocean. I think this is the most ocean we may get. I may have made the oceans a little bit too small. But this is all shores, so it should theoretically be closing in on making an ocean here. So that's just a simple way of just kind of tweaking it here and there to make the biome mapping just look slightly different in case you want less oceans, more oceans. So I hope those two other examples help you out on your world generation journey. Alright, so the next thing to go over, this one will be hopefully really short, but it's the rest of the defining of the biomes. I won't go into necessarily too much detail about it because you can get into a lot of detail about it apparently, especially with how the fog in the environment works, which you can just see in action there. But specifically what we'll be dealing with is, again, this asset node editor. So I'm going to go back and open up the biome of the Mytega 1 river, which is right here. So going down the line, we went extensively into terrain because I think that's one of the main points of world generation is the terrain. The second most important is the material provider, and essentially determines what the ground consists of and what the air consists of. Now I know that sounds kind of weird, what does the air consist of? But that mainly just means if it has water or not. So this river one here is actually the perfect one to test with this. So I'm gonna go ahead and reconnect actually the terrain back to what it was before. But yep, you can see I'm carving back in the river terrain again. And from what you can kind of tell is that the material provider can be quite simple. This isn't counting like the boulders and stuff, that's going to be a different part, as well as these logs. I'm just talking specifically right now about just going from grass to dirt. My speed is still crazy fast. Grass to dirt, and then just going all the way into the stone. However, it is a little bit different in the terms of along the shore you can see that there are actual gravel patches, and in the actual river itself there's gravel. So let's see how exactly it works. So going into here into the material provider, you can click on it to kind of see where the nodes go, which is very important if you have, for example, the props, to see just how many props there are, which realistically you should have a link to the children, which kind of organizes it a lot more, I would think. But this is how Hytale have done it. Maybe the link was added as a feature later. But let's first go on to this material provider, which goes all the way over here, and this is essentially the base node. Again, I have a list of what all these material node providers do here, which is very useful, and I encourage you to go check it out. Again, this is the base one, where you have solid and empty. Again, this is if the noise value is greater than 0. If it's less than 0, it'll go to empty. So for the ground, you will go into the queue, and how the queue works, this is very similar to how Minecraft does it actually, is it goes into a sequence. So this is first evaluated. If this is true and it places bedrock, it does not evaluate anything else in the queue. It will only evaluate the bedrock, which, as you can guess, is very important, as you want to make sure that nothing replaces the bedrock and you can't get essentially below the surface. And this is using a simple horizontal provider, which is very similar with, you could see with the density, where you had the base height, it was calling a global variable base. This is again calling the global variable bedrock, and then it's just going one up from the bedrock and then going pretty much at the bedrock, and it's exporting it as a constant material. This is always going to be at the end of whatever material provider you have, as it will always link to the material, which is the rock bedrock, which is whatever you define. So after that, after it defines the bedrock, it will then go into the river pebbles, which I assume is the gravel that I was talking about. You can also middle click to check, and yep, it is all the pebbles here. So going back, the pebbles are defined going all the way back here. It is most importantly importing the density of the world river map, which went all the way back to the biomapping to determine where the rivers are, and then based off of this density, as well as a little bit of noise, presumably to add in a little bit more of these pebbles along the shores here, it adds them together and then goes into this field function. Now the field function functions very similarly to the mixed density function, to where any noise values that are mapped between -1 and -0.88 will be specifically the pebbles. Now I don't know why there's necessarily a queue here. I guess you could add like another field function in here to add like a little bit of noise to go from like pebbles to like stone, so you can kind of mix between them. Or you could also do, which I'm actually going to try out right now, you can also do a weighted one, I believe. I haven't actually seen this used in any of these node editors here, so I don't know if it actually works. I don't know what the skip chance is. Maybe that just skips it over and then goes to the next thing in the queue. It also has a seed, which, because again this is randomized, so I'm gonna add in the weight of weight of 1, and then a weight of let's say a little bit, or I'm gonna put this as a weight of 3, and then that one at a weight of 1. And then what I want to do is, again, at the very end, you always need a constant material provider. Constant material provider. And then I want to do, whoops, I need to just do the material. And then material. It could be cool if these were like kind of grouped up as the same thing, which I guess technically you could. You could be like, hey, this is specifically, you know, just soil pebbles. And then you could just import it. Yeah, import the material provider as soil pebbles, so then you don't have to keep on doing it over and over. But I don't think it's necessarily worth it to do that. Instead, you could just do this. So I'm gonna do again soil pebbles, and then I'm gonna do the best way to actually determine what blocks you want is to search them up. So I want to see what cobblestone is, and you can see it's rock, stone, cobble. Which is very useful. Yeah, you don't want the actual name, you want the ID, which is right under it. So going into here, rock, stone, there's a bear coming up to me, which was a little bit frightening, but I'm in creative. So let me save this, go back in, there's the bear. And then instead of reloading all the chunks, now I can just do a viewport radius of 2, and you should see, bam, right in there. It's a weighted provider with a little bit of cobblestone mixed in. Now theoretically, I would want to like change this going in between, like looking up all of like the stone blocks and seeing what would look best like mixed in with this block, like maybe stone. Yes, stone would actually probably look a lot better mixed in with it. So I could go back in after I get the ID, rock, stone, and changing that to that. And as soon as I hit Control S, it will update in-game, and it will also remove any blocks, by the way, that you place in here. Just as a little FYI. So you don't want to necessarily do any of these techniques in a forever world. But yeah, you can see an example of how you can change the material modifiers a little bit. So let's continue further and see what else we have here. Now eventually I would want to collapse that into its own thing here, but we'll continue along. So next thing in the queue here is a simple horizontal, again sort of like the bedrock here. It's checking the base going from 170 to -30. This isn't too important. I imagine this is just for performance instead of checking from all the way to the top of the world all the way to the bottom. If you know approximately where the top of the ground is, I would recommend putting this specific simple horizontal provider to just not have to check the whole world. And the reason why I'm talking specifically about the top of the world is because it's using this space and depth material provider, specifically depth into floor. This is again the beginning depth of the world, so it's essentially just the top of the world. Theoretically, you could rename this to other layer contexts, but I don't know what other ones there exist or if this is the only one, as it's not necessarily a drop down. Again, you just type into it, which actually I skipped that on here as well, that it does the same thing. So you can see here, this is actually the horizontal provider is just checking within like 20 blocks of the water height map, and it's going only a depth of 3. So actually if I go over here and I go 1, 2, 3, it then goes into the next, whatever is next in the queue. And if you're thinking like in Minecraft, how you have kind of a range of depths, instead of having a constant thickness layer, you can instead do like a noise thickness layer and then have that same go through the same material and then just provide a density. However, again, it will only go as much as the max expected depth, which again I assume is only for performance, because you can also just again define the thickness using this constant thickness layer here. But yeah, so going back into here, depth into floor 3, again this is only going for the top 3, and it specifically has a group of different types that can spawn that is not along the river. So you can see there are different patches of different parts of the world here. You can see that there's like pebbles, there's whatever this is, the leafy soil, and this is now determined by this second part here. So yeah, let's go back to, where is it, this part here. This is another field function using a density. This density is specifically determining if there is water nearby, to just determine that, you know, it is away from the water, which I don't necessarily know why it does that check, because it would have already replaced everything around the water to be that. I don't necessarily know why there's like another height mass to determine that, but regardless, we're going to go into another sub queue. This will be slope pebbles, which it looks like is probably world river map. which it looks like going through here, it is a little bit complicated because I think this is already kind of done at this part here, but it is adding a little bit more pebbles along the world river map. But this may be like, since it says slope pebbles, this may be like looking at it and determining what has like a high slope. Like for example, right here has a high slope, and it's not necessarily pebbles. It is actually gravel, which it looks like this is what it's doing. It is just querying that other height map and just determining that, hey, if it's within this range of values using a little bit of extra noise, it is putting both, it looks to be gravel, sand, and gravel, which it is kind of just doing, again, that kind of field function modifier. So theoretically, yes, you can see that anywhere that it does have this area, it is kind of mixing in between the two using that, again, density function, which I think definitely looks a lot better than just having a weighted function as I did here, because it's a little bit sporadic and a little bit just completely random besides having these patches. Alright, so moving on from that, it then goes on to needles, which is doing the soil needles. Again, all of this is just adding little patches here and there of different types of blocks. But again, it goes from top down in terms of priority. So it'll first spawn the slope pebbles, then the needles, then the leaves and the grass. So if we look, again, this was the grass over here. This is the last thing that's called. And then over in this patch, you just have leafy soil. But one other aspect of these functions here, which you can see specifically with the more grassy layers, like the soil leaves and the soil grass, is that you have another space and depth, and then for each layer you have thickness 1 and then thickness 2. This isn't like priority based. Instead, it's just saying, hey, for the first layer do this, and then for the next 2 layers do this, and then you can add on to it for like the next 3 layers you can do something else, and then that's how you're able to get grass and then dirt. So if I go back, you should be able to see that it goes from grass to then dirt and dirt. And then after that, it will call the next thing in the sequence, which I imagine is very simple, which is going all the way back here and is just doing rock quartzite actually. So if I query this, it'll be quartzite. Cool. And then it'll just be quartzite all the way down. There's one last thing, which is the empty, which will want to place either empty or a water source. This is again a queue. If it's between the water layer or 8 layers below the water layer, then it will be a water source. So if this river actually goes 8 blocks or further than 8 blocks below, it will actually just be air. So you do need to make sure that you know, your noise function matches up with your material provider, because they do work hand in hand, and is again why having the importing and exporting of the density is very useful. Because again, this river map is again using the world river map to make sure that it places pebbles along this specific area right here. But the next thing on our to-do list is the props. Now I haven't actually looked too much in depth at them yet, so this will be the first time looking. But I will be sure to add that onto the nodes here. You can see that as the next thing on my to-do list. So the first thing that always comes with the props I found is this runtime thing. This runtime number is very important, and Minecraft does as well, in the terms of you don't want 2 features to collide with each other necessarily, and instead you use this runtime feature to make sure that one spawns before the other. So runtime 0 I imagine will spawn first, and anything with runtime 1 would spawn next. Yeah, so runtime 1, so first it'll try and spawn the ruins, and then it will try to spawn the boulders. And theoretically, hopefully you should be able to prevent boulders from spawning inside of ruins. But I know in V1 that is a little bit of an issue, but that is why the runtime is important, to make sure that the order of operations is done correctly. So the first thing that it does here is the positions, and yes, so as you can see, there are a different list of positions. Specifically, I believe this is calling for 2D positions, as a lot of them show here, and it's using, again, this mesh point generator, which is how you do the cellular noise here. And so for every like 8x8 area with a little bit of 0.5 jitter, You will have a mesh 2D position. This just converts the the points into an actual position coordinate system, and then in here it'll set a 2D position of where things can spawn. But as you can see, all these eventually will go off into an imported assignment. You do have a couple other ones, like a weighted assignment where you can have like a list of assignments, I believe. Yes, so as you can see here, similar to what I did before, a weighted one, but I believe if you go into the, let's look at the Taiga 1 Rivers Boulders actually, which is over in the asset editor, and then let me go back to Hytale, and then in the assignments assets, this is where all of the specific assignments are imported. So as you can see, all that you really do in this biome node editor is to define the 2D positions as well as call to an assignment, which is over in the asset editor over here in the assignments asset under the Hytale generator. But a little bit more complex example that I found over here is it actually uses an imported density of a Taiga 1 Rivers trees clearings, which I imagine is created somewhere else. I don't know exactly where it is, but the thing that this does is that while these 2D positions are here, not all of the 2D positions will be used. Instead, based off of this imported density in this curve mapper, you'll only have specific regions, well, 0.3, 0.4, 1, and 1. So it's only in these regions and a little bit of these regions that you'll actually have the trees spawning. So let's go over to assignments now, which is the next part. Let me quickly check. Yes, okay, so you can actually load this in the node editor as well. You can tell based off these positions here that's specifically for the the node editor. So let me go back to the editor and let me open it in here. So right in here, it's all loaded. So let's just start right down here to the very root node, which is the field function assignments. So yeah, this will determine which tree it is based off this simplex noise, and then using the delimiters so from -1 to 0, it'll be these trees, and then from 0 to 1, it'll be the standard aspen and fir trees. So let's start all the way over here. This is using another field function to determine if trees are dead or alive. Again, making sure that you have a different seed, or else it'll generate sort of the same noise pattern, which wouldn't work too well in this scenario. So breaking it up, again, it's to -1 to -0.5, so this is a little bit less to see the burnt ones than the cedar. So starting here, you can see that it is a constant assignment from that one going into a prefab prop. Now I'm probably going to speed past this a little bit because I haven't actually seen this, and this will be seeing it for the first time, same as you. So I encourage you to go and check out what these nodes do. I will probably be including them and looking into them into this terrain Excel file that I have here. But for now, let's look at what it is and see if we can see what it is. So we have weighted prefabs path, we have 2 weighted paths, we have trees, cedar burnt stage 1 and stage 2. So stage 2 is a lot more common. Stage 1 is a little bit less. And actually, let's kind of see a little bit of how this works by actually pulling up trees, cedar burnt stage 1. So I have experimented around a little bit. As you can see, I just hit tab. Let me just put this here. And in the creative menu, if you go all the way to the end here and you do the paste tool, you can see if you go here, a whole bunch of things in the legend here. I can press L to open it or close it. And the important part is hitting E. In here is where this is all defined. So you have trees, cedar burnt, stage 1. So let me actually just go in here. Trees, oh whoops, I accidentally double clicked. Trees, burnt, wait, what was it? Cedar burnt, and then stage 1. And then as you can see, there's only one asset in here, but I believe you can call to multiple assets in here. Let's see if stage 2 maybe has a few, or maybe stage 3. Sometimes you can have a list in here itself, which is very useful if you want to have another randomizer in it. But so essentially this is what's going to be spawned here, and you can kind of see essentially how it will be placed in the world. So you can see here, you can see how it is like a stage 1 burnt. The bottom is being burnt and the top has been burnt yet. I imagine stage 2 will probably be a little bit different, but the main thing I wanted to show is that this is what these paths are calling to. You do actually have these paths in the server assets as well. Under prefabs, you have that same list, which you won't actually get in the asset editor here. You just have the biome assignments. But another thing that I don't know if you can exactly do or not is dynamic prefabs, because as you can see, moving it around, it is only one type of tree. So if you want variation in this tree, you would have to create a whole bunch of trees and then save them all. Alright, so heading all the way back here to the directionality, I'm not entirely sure how this works. I thought it would like change the rotation of like how the tree is placed, so like hitting R, you can rotate it around. But if anyone is able to help me on that, be sure to leave a comment. The next thing is the scanner, which is actually the last thing listed here. And it looks like this scanner works by assigning the Y value of where it is, because if we go back to the other asset node editor over here, if you remember, this is specifically into 2D positions here, but for the actual Y value of where it's placed, you do need to have a scanner. And this is checking from that base value, going up 0 and then going down to -10, and just pretty much as soon as it hits anything solid, it looks like it's just going to place, which then just allows it to be placed on the ground here. So then going on to cedar, it looks like cedar is a lot more complicated for some reason. Let's just take a quick look. It's a union prop, so I imagine it's combining multiple together. You have cedar, tree cedar stage 0, 1, 2, and 3. Now what this may be doing, actually, now I think about it, is adding leaves and sticks and twigs around the base. But anyways, going here, you can see that it has all the trees. It has a block mask, which I think I forgot to go over the block mask there, but it is an imported one, so I imagine it just says what you can and cannot place Taiga 1 trees on, which I imagine would just be grass, both the grasses, maybe dirt, but then not any of the gravel, sand, or gravel rocks, which is a very important thing to distinguish between. You have the random directionality again, which just seems like it may be using these values to determine a random directionality from that. And then right here, it's then using, again, that column scanner to then place it down. This is placing a cluster prop, so it's probably a lot of props around the main area, so it's not calling like one rock. It's instead combining another prop, which will just be a cluster of props, which is using a distance curve, so yeah, preferably close to the tree. Imagine this is also going in order, so if there's a log that spawns, it's not going to place a rock in the log. And this is using a weight of 1 to place sticks. Yep, okay, cool. So this is again another sticks. This is checking for static directionality, so it won't change the rotation, it'll just be rotation 0. And actually it looks like the column prop is very cool in terms of it just able to place a block, which, yeah, that's all that you can really do with it, which is really cool. You don't have to like create a new prefab just for the sticks. This is again checking from 5 to -5 from the base to make sure that it places it on top of there. The floor pattern, I again don't know. It kind of uses the same functionality. I assume would determine like you can't place it on anything that's not this. And then the scanner checks to make sure that it's, again, there's a block placed on it. And then the last thing that it's placing looks to be plant crop stamina 2. I don't know what that is. I guess I could easily search it up as long as I'm able to search it up like that. Plant crop. Okay, cool. You can also search it up by ID. Stamina 1 and stamina 2, so it's just gonna be common that these stormcap mushrooms spawn around these specific areas. But yeah, that's what it looks like that is. I don't imagine there's anything else different about this. It's getting a column prop, scale 1, just making sure that it's within that distance. Looks like it is a very small probability that that happens, and checking that it's on top and doing the pattern. Cool. Yes, that checks if it's dead or alive. Going back to here, this is another weighted assignment. I imagine I can probably skip this over as it does a very similar thing. Now, I wish we could see where this block mask is, but I imagine you could just provide a list of materials to put in there that says you can or cannot place. You also have an advanced one, which is very interesting, and I don't exactly know how this works, but it's the thing that's there, and I encourage you to go out, explore, figure out, and see what you can do with it, what cool additions you can do. But that looks like that's all for the assignments. So going all the way back here to the to the biome again, is the environment provider. Now this one is very simple. Actually, this one is a little bit more complicated than I anticipated it to be. Typically, you just have a constant environment provider. Again, the environment provider is what is shown here, environment zone 3 forest, which then is able to determine a lot of other things, which I'll get to in a second. But first, I want to see what this is all about. This is again a mix or a delimiter based off of it looks like just the height map. So it looks like this pretty much says that anything starting from 10 blocks below the base up is going to be delimiter 1, and then anything below 10 blocks is going to be delimiter 0, which I imagine is just going to be, yes, for caves. So this is caves, forests, and then this is just forests. So actually I can easily test that. So if I go 10 blocks below 110, so to about 100, should see that it changes to forest caves. And it's not necessarily, which I don't know why that is. Although I guess looking here, I see why it's not working. It's because it's actually going from 0 to 2 and then -2 to 0. And this is going from 1 to 0. So it's always going to be the zone 3 forest. So I can actually fix this by calling this and then saving it, and then I should have my little section that will reload. And you can see that it actually changed the color of the water, and that is because of the environment. If you go into here, it's now caves forest. So theoretically this value of where it starts doing this should probably be a little bit lower, to like -20, to make sure that it's able to account for the river that's in there. So if I save this and then go back, the river should change color back again, and then once you get deep enough, it'll go into the caves forest. So yeah, I'm not going to go too much into detail with the environments. The environments you can replace or call to. In here, this is zone 3, so let's do environment zone 3 forests. It'll define the water tint. A lot of this I can actually just show here. The environment will have the water tint, the spawn density, it's just a value. I don't know necessarily what this is for. The tags, which I also don't know what it's for, but there are some tags defined. And then the weather forecast IDs, which the weather forecast IDs go in reference to the weather ID, which is also in the asset editor over here in weather. And you can see if you go into zone 3, you then have all of these different essentially weather patterns and what it will look like. So if it's raining, this will be how the stars look like. This is the fog distance, this is the particles, this is the colors, moons, clouds, and it defines a whole lot. So for example, you could have the forest looking all nice and blue like this, but if you go deep enough, you can have it change into a different color. But that is all that I'm actually going to go into right now for the environments. Let me close out of that so don't keep on opening it, because I mean it seems pretty self-explanatory. I mean you really just need to go through like all of these values if you want to change something, which can be a little bit tedious, but gives you just a whole lot of control if you really want something like a blood moon, for example, and what exactly the sky and all that will look like during that blood moon. But anyways, going off of the very last thing here, and then kind of gonna wrap it up with some considerations for creating biomes, is the tint. The tint here will define very specifically the grass tint, and I believe that's it, because the environment already defines the water tint. But it is very cool that you can define a custom tint based off of a noise map to make the biome look a little bit more varied instead of having just one tint color as Minecraft biomes would do. So as you can see here, just based off of that tint, you're able to then do delimiters again to then define very slight color variations in your grass. So for example, something that I can do is I can just literally replace it all with a constant tint provider that would just make it be all like black grass by doing this. Which would be, yes, linked up into here. I hit save, I go back, and the grass is now tinted black. Oh, that's interesting to see. I wonder what, oh, it's a blood moon. Oh, cool. So blood moons do happen in this environment. It's already defined. That's cool. It's actually really cool to see. But anyways, yeah, so it looks like it doesn't define the leaf colors, it's just the grass. And again, you can make it like variate between different colors to go to different locations. So that is a rundown of it. I don't know how long this video is, if I've split up this video into multiple parts or what, or if this is just a mega video, because I do want to get to other things with the terrain here. So now actually I want to go over the very last thing. You've learned all of the technical skills, hopefully, to be able to start experimenting and really define how the biomes work. But now I want to go a little bit into some considerations that I've included on my little whiteboard here that handle the creative aspect of creating those biomes. And the first one I have here is actually one of the big things that differentiates between Minecraft terrain and Hytale terrain, and that is how terrain is generated. In Minecraft, terrain is generated first, the biomes are applied afterwards. So as you can see here, it doesn't matter what biome it is, the terrain is going to generate the exact same. This is by doing some like very fine-tuned splines, as you can see a little bit of in that little picture there. And then from that, determining, hey, based off of a temperature map and the elevation of it, as well as a couple of other factors, what biome can be placed here. So for example here, I think a plains would look good because it's generally flat terrain. Up here you can see it's more higher elevation, and then more of the like stony peaks or cold peaks are going to be spawned here based off of other height maps. However, going over to Hytale, how this works is by defining the biomes first and then defining the terrain based off of the biomes. Now, while this is really good and I enjoy, and is the reason why I don't necessarily like Minecraft terrain generation very much, is because you can't necessarily change it from that, and you can't have any unique biomes with like unique things like this. Like you can't do this in Minecraft. It does come with its comebacks, and is the reason why Minecraft still uses one general terrain generation, is because it can have harsh borders. You can see this a little bit here, going from the shores here, going all the way up into the redwood forest here, and that because they have two different height maps, they just don't really blend well. And so then it creates these like large cliffs and large drop-offs in a lot of areas that aren't necessarily really good to traverse. But you can actually see it in the V1 version of Hytale's World Generation as well, because in V1 everything is pretty much flat. Nothing has that like any high elevation or any cliffs or anything like that. It's all just a general flat land, and that's to prevent any harsh borders like this happening. And you can see that whenever there is any like purposeful like height changes, like specifically in the biomes in V1, it does just have cutoffs of like ocean and then deep ocean, and then go to the shore there are just harsh cutoffs. So that is one of the major considerations to have with having separate biome noise maps. And one of the things that I do recommend for that is sort of doing a both approach. That have one like global height map that you can cache and then export, that is very just general, just like, hey, this is ocean, this is a very sloping ocean that goes into land that goes into a mountain perhaps, and from that being able to import it and then define more specific world generation on top of that. And then moving on to the next consideration is that while you may have like really cold biomes and really hot biomes, or really vegetative biomes and sparse biomes, it is always nice to have in-between biomes. And this could actually go very much alongside the not having a global height map. You could instead actually just have a biome that goes in between, for example, a high biome and a low biome specifically, and just have a medium biome. Because as I said again, this shore biome is very much designed to kind of transition between the land that is a little bit higher up and then transition down into a possible depth of the ocean at the end here. A Minecraft example of this would be like the sparse jungle. Whenever they're making caves and cliffs and redefining how the biomes were mapped and all that, they realized that there was sometimes a harsh border between a very open plains like this and then all of a sudden a very vegetative jungle. So in between, they were able to add a sparse jungle, which just has a few trees that can then transition into a full jungle. So again, it's just like a little thing to note while you are making biomes, is that you may want to have a little bit of transitions as you go from maybe one very unique biome to another very unique biome where, you know, the blend may not be well. And another tip for that, again, if you have like a very cold biome and a very hot biome, as you can kind of see there, is that you may want to have not just a continental noise, but also a temperature noise, to where you can map biomes not just based off of if it's inland or not, but also based off of the temperature, if it's cold or if it's hot. And so that would also easily be able to add some transition noise into like extremely hot environments to extremely cold environments, just having some in-between biomes to not make it so drastic of a change and make it look a lot more natural. Alright, and so then moving on to the third one is caves, actually, and a little bit specifically more about the water in caves, which I don't think will run into the issue here, so I may actually go into just the regular taiga. Alright, here we are. So caves, let me disable my collision, are sort of their own beast unto themselves. You can see here that they actually have some pretty good caves, actually, that are spawning in here. But these more look like, I guess, comparing it to Minecraft again, more like the caves and cliffs types of caves that you see. And that's simply because these caves are made from noise patterns. Makes sense, I mean, everything else is made off of noise patterns. However, I've just found that noise patterns and from a lot of the complaints that people have about current caves in Minecraft, that they aren't necessarily that fun to traverse in, can be quite large and have like little pockets like this they're just kind of hard to navigate. Which is why in V1 of the terrain generation, you have Carver caves, which is very much using a more, I guess, mathematical approach, or maybe, I guess because of how prefabs work, maybe using a defined carved cave structure that can carve out caves in a very specific pattern. But I do kind of think that caves do kind of need a combination of both these open areas right here that could have more like lush caves or like essentially just biome types of caves, or having like an ice cave or a hot cave or something like that, which you can also kind of see in the Hytale V1 world generation. You do, once you get to a certain depth, it does get into a little bit more openness and a lot more like lava and stuff like that. Oh, okay, well this is a cool like little cave thing that you can, little cave biome that you can have. It's apparently one of the prefabs. I was wondering if they had caves as a prefab to where it like that's how it's able to carve it out, but it may currently be like a hard-coded way that they make caves in the V1 version. And another thing with caves is actually its collision with water. Ah, yes, perfect, I found it. If you can tell, the chunks are still loading in, so the fog's close. So the interaction of caves and water. Now, that's that's a shark in the water. So this issue here you will want to be a little bit cautious of. Now the reason why this is generating with water here is because in the mountains, caves are set to generate. But in the shore and in the ocean, as you can see, no caves are meant to generate. And here's the thing I was saying before about the harsh biome borders. Now you may be wondering why caves aren't spawning underneath shores and underneath the ocean. And that's for this very specific reason right here, is because if the caves were allowed to just continue to generate as they went along here, they do have a chance of opening up and going and hitting this water. At which point, what do you do? Minecraft does this very specific thing of creating aquifers. If there's any caves that generate near the ocean or near any rivers, they will specifically spawn with water all throughout the cave, which I wouldn't be too sure of how to exactly, or I'm not exactly sure of how Minecraft is able to do that. I would have to really look through the source code, as it's a very hard-coded feature currently. But that is one way to solve it. An easy way to actually solve it here is just that for the shores here, you should be able to, in the empty field, which, let me see if I can open it up here, in the material provider for empty, as you can see here, this is pretty much what it's doing at the shores. It's setting a water source if it's essentially going from the water all the way to the bottom of the world. But what you can check is if the cave noise, which is I think imported somewhere over here, if you import the cave noise, if that position is supposed to be where a cave is spawning, also setting it as empty to make sure that this doesn't spawn. However, this doesn't get rid of the issue of if you have this cave noise going all the way to over here, that it won't intersect with an ocean and then cause just a weird like open issue where like the water just kind of flows into here, which I'm sure you've experienced in the V1 cave generation, in that you just have kind of water spilling in like this. There are a few techniques that I know to get around it. One thing that you can do is just make sure that the Y value of the caves don't spawn close enough to the water, so like caves would only be able to spawn like up to here, and then after that have them stop so they don't like hit the water, especially since you could, if it is spawning in the middle of the ocean, like a cave could just spawn like this, which would cause an issue of just having floating water, essentially, which would be a little bit unfortunate. And I'm actually not even creating a cave, I'm just causing the sand to fall. But yeah, so you'd have something like this, which would then, you know, not have water filling up, which would look a little bit weird. So again, just another consideration, there are multiple kind of ways to go about it. Whether you do what Hytale does right now and cut it off at the shores, just make sure that any specific scenarios like this, you can either leave, I mean it does kind of look cool, or you can just query the cave noise and then just make sure that it is empty in this position and not like continued forth. And then another thing you can do is that just make sure that the cave generation never goes above the ground level, or at least the water level, as it reaches more of the rivers or the shores or the ocean. Or you can do the Minecraft approach and figure out some way to include aquifers, where if it gets close enough, everything will be water until it like reaches a certain area or something like that. The next one on my list is travelability. I talked about this a little bit with the biome blending. Just make sure that the like all of this is about the player and about the player exploring. You may be flying around and all that, but the player is most likely just walking around, and you want to make sure that you can easily traverse, because while big open caves may look cool, or while huge cliffs may look cool, they can be hard to navigate. And so it's just something to consider as you are doing your creative endeavors. This is kind of cool to kind of traverse up here. It's relatively easy too, and then you can eventually climb this cliff here to go all the way up. And finally, speaking of the player and the player's experiences with the terrain, probably the most important factor, there's a bird in this cave, probably the most important factor is to tell a story, because it may be one thing to make terrain look like this, but to be able to have these huge cliffs with a dragon living at the top of it, that tells a story. That makes a unique, interesting point that draws your eye and really captures your attention with the biome. The V1 world generation also does this with the Azure, with the blue biome, where everything looks blue. You have really interesting trees. It really calls your attention to it, but that doesn't mean that all your biomes have to be very noisy, very interesting looking and all that. And sometimes you just need a very calm, just plain biome to be able to navigate between places, to be able to navigate to these huge cliffs or interesting terrain off in the distance. And on top of that, even though I didn't necessarily go into the assignments that much of putting these structures in, it is also important to tell a story of where these structures are being spawned. Like, for example, I think it could be very interesting to have a village that's just right next to this little river here, and then they have a specific water wheel that's right next to the river that's able to generate power for whatever they need in their village. And plus, with it being a very nice flat terrain, for one, it doesn't require any complexness with placing in the features in case you don't want like a village falling off of a cliff or something like that. Instead of having the village be in this nice calm area where a village would live, and being right next to the river, where you can probably find like a fishing dock or something like that as a part of, telling a story of what the land has gone through. Even having like a specific village up here that is very much designed to maybe hide amongst all the mountains, or like Lord of the Rings, where you have the watchtowers at peaks to be able to communicate to each other. Have a specific tribe, it looks like, using the mountains to communicate, and just being able to tell stories like that. I mean, Hytale is all about being a mystical place. But that is that's pretty much the last thing I want to leave you off with on this either very long or series of videos of creating world generation. I hope that this has helped you learn all the technical tools and hopefully also a little bit of the creative tools to really experiment around with this. I recommend going and using your knowledge of all the technical tools and creative tools to look back at things like Minecraft or whatever other procedural game that you know of, or even looking at Hytale, seeing how they generate it, what you really enjoy about it. Like for example, I just really like I keep on going to these cliffs of these 3D markings of it. You see they use a 3D noise map to generate the boulders off of here, but then they use a material provider to then mark these insets with a darker block to really pronounce what is happening here. But yeah, I would love to see where Hytale goes, both themselves and the community, with all of these just features that are allowed for modders to be able to create just cool biomes like this and cool just custom terrain like this. I'm definitely going to be going in and trying to create a multitude of different things, and I encourage you to leave a comment of what your I guess mod is called. You can't really leave links or else it'll probably get deleted off of the comment section. And also again, leave any comments. I'm sure to read them and respond to them, and I hope that again this has helped you. But now I am going to go off on my own journey. And so subscribe if this has helped, and I hope to see you again very, very soon. I gotta go rest my voice. I've been talking for 3 hours.